Okay, so here we've got to prove that this recurring decimal is the same as this fraction. So the word prove implies that we should start with a letter. So we'll say let x. So let x equal the recurring decimal. Now remember what recurring decimals look like. So they go on forever. They're telling me that the 2 and the 1 repeats because of the dots. So it goes 2, 1, 2, 1, 2, 1 on forever. Classic way of doing this is that we find out what 10x's are worth, 100x's are worth, and 1000x's, and if we need to, we just keep going with multiples of 10 until we find that we get two parts, two equations, where the recurring part is to the right of the decimal and next to it. So what we're after is we're after 0.21 recurring in two of them. Now it might be 0.21 recurring, it could be 21.21 recurring, but we need two equations where the recurring part is to the right of the decimal and next to it. So if I do 10x's, that means this all moves up one place, so it becomes 0.21 recurring. So that's given me one equation already where the recurring part has come next to the decimal point. 100x, well, that means this moves up two places, so the 2 becomes at the front, so it becomes 2, 1, 2, 1. So the recurring bit is now here. That's not next to the decimal point, so that's not going to help us. So we do 1000x, that means it's going to be 21.21 recurring. So we've now got two equations as we wanted, where the recurring part is next to the decimal point to the right of it. So I can now do a sum where I'm going to do 1000x's, take away 10x's. Well, that's the same as doing the 21.21 recurring minus the 0.21 recurring. Well, that's done what we wanted because 1000x take away 10x is 990x. 21 take away 0 is 21. But the recurring bit cancels each other out because it's like saying 2 take away 2, 1 take away 1, 2 take away 2, 1 take away 1, and so forth all the way forever. So we've ended up with this equation. Solve for x by 990 times, so divide by 990, so 21 over 990. We recognise that both of these divide by 3, so 21 divided by 3 is 7, 990 divided by 3 is 330. So what we've done now is we've said let x equal that, so x equals the recurring decimal. We've also found that x equals this. So therefore we've proved x equals 7 over 330 and x equals 0.021 recurring. So 0.021 recurring is equal to 7 over 30 because they're both the same as x. So that's the way we could prove that a recurring decimal is the same as a fraction, or we can turn a recurring decimal into a fraction. So one more quick example. So say we had the recurring decimal 0.47 and it was just the 7 that was recurring, and I want to turn that into a fraction. So again, we could say let x equal 0.47 recurring. Now we've got to remember what that looks like. So it goes 4, 7, 7, 7, because it's only the 7 that's recurring. So it's a classic technique, do 10x's, so that means it moves at one place, so that becomes 4.7 recurring. Do 100x's, so that means it's 47.7 recurring. Don't need to go any further because I've got the recurring part next to the decimal point in two equations. So we can do 100x, take away 10x, so that's going to be 47.7 recurring minus 4.7 recurring. So that's 90x is equal to, well, 47 take away 4 is 43. The recurring bits have cancelled each other out, so we're left with just that. So x is 43 over 90. Now this kind of question is normally on a non-calculator paper, but obviously just to check that it did work, we could use our calculator just to quickly check here. So 43 divided by 90 equals 0.4 and then the 7 recurs. So that technique is the way to do recurring decimals into fractions.